Conservation of angular momentum and rotational invariance isotropy of space. The space simultaneously possesses the property of linear uniformity and rotational invariance. The space simultaneously possesses the property of first, linear uniformity, and second is rotational invariance. Therefore, form of potential energy function U R1 and R2 equal to U are where R equal to mod of R vector R equal to R1 minus R2. Therefore, the form of potential energy function U R1 comma R2 equal to U R, where R equal to mod of vector R equal to mod of R1 minus R2 vector, comma R1 vector and R2 vector being the space coordinate of the two interacting particles P1 and P2 respectively satisfy both the condition stated above. The potential U depends upon the magnitude of the separation of 2 points R1 minus R2 but is independent of the actual value of the space coordinates and their direction. The force on the particle P1 equal to F21 vector equal to minus del U upon del R1 unit vector R equal to minus del U upon del R into del R upon del R1 unit vector R1. The force on the particle P2. The force on the particle P2. The force on the particle P2 equal to F12 vector equal to minus del U upon del R2 unit vector R equal to minus del U upon del R and del R upon del R2 unit vector R. Okay, where R cap is a unit vector along a vector R, the direction along which either force of interaction acts. Two cases arises. First cases, force of interaction acts two cases arise. First case is R1 is greater than R2. In such R equal to R1 minus R2, so del R upon del R1 equal to 1 and del r upon del r2 equal to -1. Then the force F21, force F21 equal to minus del u upon del r unit vector r, and force F12 vector equal to plus del u upon del r unit vector r. Okay, hence F12 vector equal to minus F21 vector. Second case, if R2 is the greater than R1 or R1 is the less than R2. Okay, in such a case R equal to R2 minus R1, but del R upon del R1 equal to -1 and del R upon del R2 equal to +1. Then the force F21 equal to plus del u upon del r unit vector r, and F12 force on 1 by 2 particle 2 vector equal to minus del u upon del r unit vector r. Okay, hence again F12 vector equal to minus F21 vector. Thus the potential function UR leads to Newton's third law of the motion, where is thus the potential function UR leads to Newton's third law, Newton's third law of the motion, whether R1 is the greater than R2 or R2 is the greater than R1. As proved above, F21 vector equal to plus minus del u upon del r unit vector r, and F12 vector equal to plus minus del u upon del r unit vector r. If minus del u upon del r equal to function of r, F12 vector as well as F21 vector can be expressed as plus minus function of r unit vector r. In other words, the force will depend only on r. The force depend only on r, the distance between the center of the two particles. It is therefore a central force. Okay, central force. Thus we find the rotational invariance of space requires motion under a central force. Now the torque tau for a force about the center of the force is given by vector tau equal to vector r cross vector f. equal to vector r cross vector f function of r unit vector r equal to fr vector r cross unit vector, okay, equal to fr into r in bracket unit vector r cross vector unit vector r equal to 0 for such a force torque tau vector equal to 0, okay, tau vector equal to 0. But a torque is the rate of change of angular momentum. Vector J angular momentum. So tau vector equal to rate of change of angular momentum dj upon dt equal to 0, okay. Integration we get vector j equal to a constant, okay. This proves the law of conservation of angular momentum. Thus the rotational invariance or isotropy of space so that there is a central force between the two particles interacting with each other, okay. A constant. This proves the law of conservation of angular momentum. Law of conservation of angular momentum. Conservation of angular momentum, okay. Thus the rotational invariance are isotropy of space so that isotropy of space so that first point of space shows that first is the rotational invariance or isotropy of space shows that first there is a central force between the two particles interacting with each other, okay. Second point, vector F21 equal to minus vector F12. Newton's third law of motion hold good. Is that Newton's third law of motion holds good. Newton's third law of motion holds good, okay. These two properties and coordinates show that the angular momentum is a constant. Hence the rotational invariance. Hence the rotational invariance. Hence the rotational invariance of space leads to the part of space invariance of space leads to the principle of conservation of angular momentum. Principle of conservation of angular momentum. Okay, thank you. Next heading is angular impulse.